Hello everybody, in this video we are going to learn how to find the cube root of iota. Now what does this mean is we need to find at least three distinct values for this cube root of I. So how should our thought process be in order to solve this question? So first we express I in terms of polar form and this is how it looks like. Now why polar form? So that in the next step we can apply the de Moivre's theorem, which is nothing but I to the power 1 by 3 or 1 by n is nothing but r to the power 1 by n into e raised to I to this angle, that is theta by n, and in this case it will be 3. And then we substitute three distinct values of theta to get three different values of the cube root. So step-by-step solution. So the first step is we convert the iota in terms of polar format, and if you try to depict this in this graphical format, you will actually arrive to this particular expression. Now the next thing is we apply the property of periodicity for sine and cosine angles. So we add this 2k pi to this angle where k is nothing but an integer. Now we take the cube roots on both these sides, that is I to the power 1 by 3 and this entire expression to the power 1 by 3. Next, we then apply the de Moivre's theorem, that is we bring this particular power to the denominator. The expression will be converted into this format. And here one thing to notice, the cube roots are equally spaced, that is 120 degree apart by this particular angle formation. So now this is where we have arrived in our previous step. So now in step 5, we put k is equal to 0, 1 and 2 to obtain three distinct values. So for k equal to 0, that is you put k equal to 0 in this expression and you arrive at this particular expression. And this is the value when you solve for this cosine of pi by 6 and sine of pi by 6. Now the next thing is you put k is equal to 1 in this expression. So with that what happens is you find cosine of pi by 6 plus 2 pi by 3, likewise sine of pi by 6 plus 2 pi by 3. Now if you convert this into an allied angle formulation, then you arrive at this particular expression. And for this conversion, you can refer to this graphical representation. So pi by 6 is 30 degree and 2 pi by 3 radian is nothing but 120 degree. If you add this up, it is 150 degree. So graphically 150 degree is nothing but 180 minus 30. And 180 means pi radians, 30 means pi by 6 radians. This is how you obtain this particular expression. So this is your second cube root and this is your one of the answers. Now ultimately we move to for k is equal to 2. And when you put k equal to 2 in this expression, then this is how you can graphically depict this. If you try to try to add up these two values, then you arrive that pi by 6 plus 4 pi by 3 is nothing but 3 pi by 2. And this is nothing but minus of I. So once again, this is another cube root. So a trick to remember this is, from the step-by-step solution, you must at least remember that cube root of I are 120 degrees apart and one of the cube root is minus I. Then you try to plot this in a graphical representation, that is minus of I with 120 degrees apart. And when you know that this is 120, so obviously this angle is 30 degrees. And then by cosine sine relationship, you try to find the x coordinate and the y coordinate. And this is ultimately the three cube roots of I.